Welcome everyone. In this video I'm going to continue my reflow plate project. So in the previous video you could see the proof of working of this device. So I put together everything on a breadboard and I was able to actually solder a circuit board. In fact, the circuit board is right next to me. So I soldered this AS5600 circuit board with my freshly made heater plate. But then of course I still have things to improve, and I also have some stuff that I wanted to fix. And one of the things which I wanted to fix is, for example, making a PCB for this device, because I wanted to have all the electronics in one place. I wanted to avoid the messy cables and so on, and since this device works with mains voltage, it's a good idea to have everything in a, let's say, neat and confined space. And this space is basically the circuit board. So in this video I'm going to assemble one of these PCBs and I will test them, and we will see how it works. So now, as you can see, I have these very nice and yellow PCBs, which were made by the sponsor of this video, PCB. And what is special about these boards is that they have a very nice and vibrant colors everywhere. So the traces and also the silk screen gives a very nice contrast, so it's very easy to see. And I have traces on both sides, as you can see. So yeah, it looks quite nice. So if you want to have similar PCBs, or even better than I designed, head over to PCBway.com and make your order. So I hope that you will use their services, and I hope that you will like their services as much as I do. So we have these PCBs, and I will just pick one, a little bit look around it, and then I will put in the parts and test if the circuit works. So now I did some changes, and let's start with these holes. I have 3 holes, as you can see. So there is one cut on the board here, there is another cut here, and there is a third cut here. And why I did these is because this corner of the PCB, especially if you look at this part and you see these very thick or very wide traces, this is the mains voltage part. And wherever I saw some, let's say, critical space between legs and traces, I wanted to separate them physically by adding a gap. And then these gaps are, I think, 3 millimeters wide or even more. So the traces are safe, in a safe distance from whatever pins or traces are on the low voltage side. And I would say that the most important part is here, because this is the place where I will place the optocoupler. So the optocoupler will switch on the low voltage side, and it will switch the high voltage side. So then, of course, one side of the optocoupler has mains voltage, and the other has, in this case, 5 volts. So it's very good idea, I think, to separate these pins as much as possible physically. So that's what I did here. And also, as you can see, these, let's say, mounting holes now a bit more fancier than previously. So in my previous PCBs, I just only used simple holes, but I discovered in KiCad that actually you can add the pads. So you can select which screw standard or bolt standard you want to use, let's say M4, M5, M3, whatever. And then you can add these pads even with some wires. So then it looks fancy, and then it can provide very nice contact as well. So regarding the board, there is nothing extra. Yeah, as you can see, this corner is the triac side. I will also have a power brick here, and then as you will see it also on the photos, the screen will come here, rotary encoder will be here, thermometer will be here, and I tried to add the hole roughly because the thermometer's board, this guy here, also has a hole, as you can see, and I tried to estimate the distance by, of course, measuring the things, but we will see if I succeed or not. Arduino comes here, and then this is just a small circuit for the transistor, BD139 transistor, PNP regular transistor comes here. That will switch two fans, M1, M2, those are the fans. So what I will do, I will start filling in the shorter parts. So for example, the terminals and some, let's say, plugs and headers, and then we will see how to proceed with this board. So let me prepare a few things, and then we will see how this is going on. So first I will fill in the resistors, and I have 5 pieces if I can count correctly. So 3 larger resistors are on the mains side, and there are 2 other resistors. One belongs to the optocoupler and another belongs to the transistor. So let's just fill them up, and then let's solder them. Okay, so I did some extra work. So I added some extra pieces which had similar, let's say, legs. So then I will also solder the PTC here, and the 2 capacitors and the diode as well. So these parts are done. The only ugly thing is this resistor here, but that will be fixed later. So now I think I will add the socket for the optocoupler, and then add the transistor and the triac, and then we'll see how to proceed further. So now one might see that if I put in this triac with its heatsink, then the heatsink would be over one of the lines here. So what I could do is either I raise this up, which I will probably do, or I just use a piece of Kapton tape, or maybe 2 pieces of Kapton tape, put it on the board to add some additional insulation between this, actually coated trace and the heatsink. So that can be also an option, but what I will do, I will just rise this up and use it like that. So as you can see, the board is more populated now. So we have the semiconductor, let's say, switches, and then the place for the next switch as well. So this is a 6-pin optocoupler. So I will just try to squeeze it in its place. Obviously I have to close the legs a bit. And it's done. So this part is okay. And now I will add the connectors and some headers for the jumper pins. So let's do that. And for the motor, now I will just add the jumper pins, but in fact I could add this regular pin which is used for fans in general, but the fans which I have are these tiny fans, and they came with the jumper pin, so yeah, I will just keep using them. And of course I also have this power brick here, which should fit. Hopefully it will fit. Yeah, it's just the bent legs, but I will make this fit, of course. And then yeah, this will sit here. So let's add the rest of the components. So we have the power block here, or power brick, and then the two connectors. This is the AC in, and we have a hole here for the protective earth. So as you can see, it's connected to the earth input here, and then the rest is just the neutral and the live. And really just I need to cut the headers for the Arduino properly, and then some jumper pins, and we are done. So I have these things I will show you, which are just, I think, 40 pin sockets. So I just have to cut them to the perfect length, or the required length, and that should be it. But of course, whenever I cut this thing, I always lose one socket, because I have to cut through the socket. So that, yeah, kind of not the best thing which you can do, but at least it's something. It's not too expensive, but still feels bad to waste the sockets. So for example, we have the rotary encoder, which is this guy here, and that will require a socket of 5 pins. So I will cut the 6th socket, and that should be fine. So 1, 2, 3, 4, 5, 6. And then I just crush this thing there. And as you could see, this copper piece, the pin, already fell out. And of course now we have a kind of a revealed place here, but that doesn't bother me too much, so this will come here. So I just put this aside until I cut the rest. So then we have the display, this guy here, and that will require a bit more pins. So it has 1, 2, 3, 4, 5, 6, 7, 8. So again, I just count them and cut the number of pins plus 1. So this is done, and it will sit here nicely. And then we have the Arduino, and I've worked so much with the Arduino that I should know how many pins there are. I think it's 15, but yeah, I just don't remember properly. Yeah, it is 15. So one side here and another side here, so this looks fine. And then I think I will use this thermometer module and just directly solder it there. And as you can see, or I can at least see, maybe if I put this white thing under this, that I can see through the hole. You see, it's bright, it's dark. So that means that I managed to find the good dimensions for this. That's very nice. So there will be a small gap. I will take pictures of this because it looks much better there, but there will be a small gap, and it actually I would not need this screw here, because if I solder the pins on the other side, then I have the other 2 pins here. You can see the legs of this socket here, which actually support the PCB of this thermometer module. So yeah, it should be fine. And then I need 3 pins, 3 jumper pins for the voltage input selector. Done. And I need 2 times 2 pins for the motor. And as you can see, I use a yellow header. It's not like it matters too much, but just makes the board more authentic with the color choices. So then 2 jumper pins go there. The 3 jumper pins go here. Then another 2 just goes there as the other motor pin. And then the display. And then we have the Arduino. It's a Nano, of course. And then finally for the rotary encoder. So it will look something like this without the circuitry. And then of course here we'll sit the thermometer, and then rotary encoder, display, Arduino. So let me solder these things. This will be a bit more troublesome, and then we will try this circuit. So now I have almost all the parts installed. We are missing a jumper pin, which will select the input voltage, and since this power brick is 5 volts, I have to put this jumper pin in between the center pin of this 3-pin header and the plus 5 volt pin. So this will redirect the output voltage of this to the 5 volt pin of the Arduino. Otherwise, if we have a 12 volt power brick here, then this pin would be on the other side, and it would connect the output of this with the plus 12 volt pin, which will then go to the V-in pin of the Arduino Nano. So let's put in the display as well. So the display will look like this. And let's put in the rotary encoder, and that will look like this. And obviously, if we would not like that these things sticking out or being wonky like this, I can fix this in a moment as well. So what I have here, which you can not really see because of my black gloves, but you can see that these are standoffs. So I have these nylon standoffs, and I just simply add it to the display, to the corresponding places. And now the display has support. So it will stand here a bit better, as you can probably see. But of course there is still a little bit of space, but that can be mitigated by adding one more standoff here. And of course also you can have this rotary encoder directly soldered here, so you can get rid of this extra almost 1 centimeter distance, and then it will not be this much wobbly, but for me it's fine. So then the final step is to add the Arduino, and I have the Arduino from the old circuit, so I just simply plug it in there. And it fits perfectly, so that's nice. And I just have to borrow this thermocouple from here. So it's not so bad that we transformed this mess into this nice and clean circuit. I think it looks very nice. So I will recheck all the connections, and once that is done, I will add the load, the heater, and I will add I will add a mains voltage connector, and we try if this works or blows up or whatever happens to it. So now I have marked these 3 connectors or 3 terminals on the board. You will see some close-up pictures of that as well, but you can see that we have earth, live, neutral, and we know which is the live. That's the brown one. So I will just separate the wires according to the order of the connectors here and screw them one by one. So there's a good fit there, that's nice. And then I just add the heater to the other connectors. That should be simple. And here actually the polarity doesn't matter, so yeah. As I can grab the wires, I can just insert them in the terminal sockets. So this would be it. Now of course this is a big mess here, but you can see the main things. So here comes in the mains voltage, we have the connector here, and then here we have the microcontroller, the rotary encoder, the thermometer module, the display, and then we have the, let's say, high voltage side, which here, this is the triac capacitor, a few resistors, a PTC. Then we have this power brick and then here we have the motor switching side, and of course the optocoupler for switching the triac on and off. So what I'm going to do, I'm going to plug this thing in and then turn on the corresponding outlet, and we will see if this blows up or not. And before starting, for fun, I add one fan to the circuit just to see how it behaves, if it behaves at all. And of course here on the high voltage side there is nothing behind the circuit, so nothing should short out the things. So yeah, let's see what happens if I turn this on. It works, kind of. Yeah, the same program starts, what should start. Thermometer works well so far, shows 30 degrees. So I think the most important thing is to see if the triac circuit works, and the only way to find out if it works or not is that we should start it. So I start the program, but before that I just make the temperature time shorter, much shorter. So let's say 30 seconds. So then, or 30 seconds. So now that will be reached quicker, and then yeah, we will see. I just want to see if we reach some certain temperature or not. So we are in the preheat phase. And this thing seems to work so far. So I will need a thermometer for this thing. So the fact that this thing works is just one thing, but what I have to emphasize is that I think I have to check a few things in the code, because I might believe that, for example, the thermometer will not behave as it should behave, and so on. But let's start this thing, and maybe let's see if we can do anything with it. As you can see, if I move this stuff, the thermometer dies because I probably have faulty wires. So first let me disconnect this, so this will turn off, and then I will make the wiring better, because this was a very bad wiring and this is broken here, so it's not too useful right now. And I turned off the AC voltage. I removed the plug, so everything is safe. And I will just make these connectors better. So now I'm touching this. I fixed the things here. It was also shorted because I twisted the wires. So now this works. It reached the body temperature. So try to plug this in inside the PTC heater, and we will see. So now I try to short down this program and see if we can reach the thing easier. So now I made a super weird reflow curve, because I just want to check the switching and stuff like that. So I just start this program and we will see what happens. So now this was a bit switched on, so now it's at high temperature, 116 degrees. So this will not start for a while, but I can already see that the chart is being drawn at the proper space, or proper place, I would say. So that's fine, and I just want this thing to follow the reflow curve, in a sense that I just want a program to finish. So of course we will not expect a good reflow curve here, but at least we can see if this thing works. And ultimately I want to see if the fan will start at the end of this program. Meanwhile this is ongoing. I unpack another fan, this one here, and add it to the circuit, just to give the full load to the transistor. And these are just tiny 5-volt fans. Actually, they are advertised as Raspberry Pi fans. So I guess it's good enough. So now we reached the soaking temperature. And according to the program, we should be at 140, 150, 160 degrees. And actually this goes up, so it follows it. That's really nice. And if I have another thermometer, we can even try to see if this thing heats up or not. And yeah, it goes up. I will try to show it to you. So it's hot. It's getting hot. And of course the target temperature is now according to the wrong temperatures, but that doesn't matter. And now what you should see, well, it's not really visible, but you see that the fan is turning, at least. I hope it's visible, both of them. So this also works. It's very nice. So I announced this circuit as a working circuit on a very nice PCB. So I think that's very cool. So this video is getting extremely long. So what I'm going to do is that I will make this program to work properly. I will also make some adjustments because the reflow curve could be improved. I will make some longer cables for the fans so I can arrange everything in a better way. I might put this on some kind of stand, and I might find some way to cover the spicy area of this circuit so I cannot accidentally touch the mains voltage by any means. So then that will be in the next video. Stay tuned. I hope you liked this video. Especially I hope that you like this PCB. If you want to make the exact same PCB, I will publish all the resources on my website, and also I will publish this PCB through PCBWay's website. So you can just click on my link. You will be redirected directly to PCBWay.com, and you will see this PCB, and then you can customize it, for example, based on the color if you want something else. I can really recommend this nice purple color as an alternative, and you can buy it from PCBWay.com. So that's very nice, I think. And you can see that this is a big board and it can be soldered with this reflow station. So I hope that you like this video. I hope you like this project. I will still work on this and improve this. I'm still waiting for a heater because I'm still using the old one. So that will be also improved, and some other tiny things will be improved. So I hope that you found this video informative. I hope you learned something, and see you in the next video.